pressure in liquids, and for this we have the hydrostatic law, and the statement is rate of pressure in the vertical direction is equal to the weight density of the fluid at that point. So the rate of pressure, which is written as dP, that is the change in pressure with respect to dz, that is the change in height. So dz, this is the vertical dimension, so the overall, if you see, this is the rate of pressure in the vertical direction. This is equal to the weight density, and the weight density is written as rho g. Rho is the density and g is the acceleration due to gravity. So I can write dP will be equal to rho g into dz, and on integrating this I'll get dP is equal to rho g is constant, which will be outside the integration, dz. So I'll get capital P, that is equal to rho g into capital Z. So this Z is called as the pressure head. This is called as the pressure head. This determines the pressure, which is actually basically what is this is the depth. If you see, let me take some layer here. Let me take a layer here which is at some depth Z from the free surface. And also I can refer this as rho g. Instead of Z I can call it as h, since that is basically the dimension. If you see, this height over here, isn't it? So I can consider that as h also. So any way we can consider. Now if I set some limit for this, for the same integration, dP is equal to rho g dz. The limits I'll set it from p0 to p, and here the lower limit is z0 to z. So what does it mean? See, from the free surface I am considering two layers. One is here, which is at some height z0. The height is z0 here, and the other layer, the height for that is z, and the corresponding pressure on z0 is p0, and for the layer here at the depth z, that is p. Now if I integrate it, I'll get p minus p0 is equal to rho g z minus z0. So since it is p minus p0, it means that p is greater than p0, and also z is greater than z0. So the depth, if you see, we have seen that the depth is more here, so z is greater than z0, and the pressure also, if for the case of pressure also, it is just the same. Pressure at a greater depth, at more depth, it will be greater than the pressure at less depth. To explain this, you see this layer which is at height z0. For this layer, the pressure on this layer is as a result of the liquid that is over this layer. So the liquid over this layer will be imposing some force on this layer, and this will result pressure on this layer. So the pressure will be less since the quantity of liquid is less here, and the pressure that we get here, that will be rho g, and the height here, the depth here is z0, isn't it? So this is the pressure that this layer will experience. Now coming to the next layer, this one here, you see the number of layers is more. We get all these layers over this, all these layers. So all these layers together, it will be imposing force on this layer, and as a result, since the number of layers are more here, the pressure also will be more for this layer. Then this equation, I can further write this: p minus p0 is equal to rho g z minus z0. Instead of that, I'll write this, I'll specify this as h. I'll consider this as h, z minus z0. So this portion. So let me write that as h. Then I can write p is equal to p0 plus rho g h. So what does this mean? That is the pressure on this layer. On this layer, the pressure, it will be equal to the pressure on this layer, that is p0, this pressure plus the pressure imposed by the layer over here in this region of the liquid. In this region of the liquid, this pressure together, they're imposing the pressure on this layer. So this is why p0 we got. P0 is the pressure on this layer plus rho gh. Rho GH is the pressure of the liquid that is present here. Together they are imposing the pressure on the layer, and this pressure is what we are getting as P. So this is the equation we are getting. We also have the Pascal's law, and the statement is intensity of the pressure at any point. So let's take any point and let's see what is the intensity of pressure at this point in a liquid at rest. So this is a liquid which is at rest. It's a very essential condition. Only at rest the intensity of pressure will be same in all directions. So from any direction, the pressure that you see on this point, the pressure will be same from all the direction on this particular point. So this is the Pascal's law.